Okay, in problem number 8, we have this circle and this right triangle. And we're told that in the circle above, with center O, that the radius is 2, and that AP has length 3 and is tangent to the circle P. Since AP is tangent to the circle, it forms a right triangle. It forms a right angle with CP, which is the diameter of the circle. And what we're trying to find here is what is the length of BC. So I'll label that with an X there. Alright, well, one thing we can see right off the bat is our triangle has sides of 3 and 4, which means its hypotenuse has to have a length of 5. And if we could, we need to find out what X is in this. And we need a strategy that's going to help us get there. Now, one thing we know is that since CP is a diameter of the circle, that we can form triangle CBP. Now, since that is a triangle inscribed on a semicircle, that has to be a right triangle. And that's really the key step to getting a solution to the problem here. What we do want to notice then is that we have similar triangles. How do we know that we have similar triangles here? Well, both of the triangles have a 90-degree angle. If we can find one more angle that is similar, that is the same, between the two triangles, then we will have a pair of congruent angles which will make the two triangles similar. Remember that there are a total of 180 degrees, and if you know two of the angles, then the third angle can be calculated. So if we know that two angles match between two triangles, the third angles have to match as well. Well, if you notice angle C here, that it is part of that small triangle inscribed on the semicircle, and it is also an angle of the large triangle. And so what we want to do is find a way to match these two triangles up so that we can identify their corresponding parts. Well, with the large triangle, we have triangle ACP, where C is the angle that is going to be congruent to the angle, to an angle in the other triangle. Now, in order to get that to line up properly, on the small triangle, we're going to have C up at the top there and B down in the right-hand corner, which means that P has to be the vertex on the left side of the base. Now, only when we have them lined up in this way can we identify the corresponding parts of the triangles there. So we're ready at this point. The hypotenuse of the large triangle has a length 5, and the hypotenuse of the small triangle has a length 4. Side BC has a length x, and side CP has a length 4. Side AP has a length 3. At this point, we can set up a proportion, and there are different ways of doing that. 5 is to 4. The hypotenuse of the larger to the hypotenuse of the smaller is 5 over 4. And the height of the larger to the height of the smaller is 4 over x. When we cross multiply, we get 5x equals 16. So that x equals 16/5. If you were to plug that into your calculator, you would get 3.2. And so the answer is C there. There are a few things that are important in this problem. One, you should be able to identify a 3, 4, 5 triangle. That'll help you quickly get the hypotenuse side. If you didn't, you could still use the Pythagorean theorem and find that. Another important thing here is that a triangle inscribed on a semicircle is always a right triangle, and two triangles are similar when they match in two of their angles. Remember that corresponding sides of similar triangles are in the same proportion.